In this video, we'll take a look at the Science Cube Smart Cart WL110SC and the lap equipment SCS500. The Smart Cart WL110SC comes with a hex key, Velcro, magnets, shock-absorbing rubber, and a USB-C cable. The magnets are stored inside the cart and can be removed using the hex key. The SCS500 includes the parts shown in the image. Now, let's perform two experiments using these devices. The first experiment aims to verify the law of conservation of momentum and the concept of inelastic collision. Using two wireless smart carts, we'll observe the momentum transfer when one cart pushes the other, and check whether momentum is conserved before and after the collision. First, let's assemble the rail and a few rail components. As shown in the video, turn the connectors clockwise to lock them in place. Since the desk may not be perfectly level, attach height-adjustable feet to both sides of the rail to level it. Also, to prevent the carts from falling off the rail, attach the stopper component at the ends. Next, open the Science Sharp app and proceed with a Bluetooth connection. Tap Connect, and you'll see a screen like this. If you connect using the built-in sensor option at the top, you can only link one cart. This allows you to collect various data like distance, velocity, force, 3-axis acceleration, 3-axis angular velocity, and forces up to 100 N. However, since our current experiment requires two carts, we'll select wireless sensor from the main Bluetooth screen. Choose the carts labeled 246 and 230. As you can see, both carts are now connected properly. After the connection is complete, Zero adjusts both carts. Then, go to the experiment settings menu at the top right and set the data collection rate to either 50 Hz or 100 Hz. This will ensure smooth and accurate data acquisition. Before starting the experiment, place the carts on the rail. The rail is about 120 centimeters long, and a gap of one cart length between the two carts is recommended. One cart should remain stationary, while the other will be pushed toward it. Now let's start the experiment. Tap the Start button in the app, and gently push cart A toward cart B. As you can see, cart B is being pushed. Once the collision is complete, tap the Stop button. Let's begin analyzing the data. If your graph appears flipped, you can reflect the y-axis using the data tools. Select distance, choose y-axis transformation, and enter -1 to invert the graph. If multiple graphs overlap or the colors are too similar, you can customize their appearance. Open the graph settings to delete unwanted graphs using the minus icon, change the graph colors, or adjust line thickness as needed. You can also tap on the velocity graph to see exact values. Alternatively, you can calculate velocity by differentiating the distance graph. To do this, deselect all velocity data, select the red distance graph, and tap the Analyze icon. Then drag over the portion you want to differentiate. A light blue velocity graph will appear. You can repeat this for the other cart as well. Returning to our experiment, the velocity before collision is 0.374 ms. After the collision, the velocities are 0.285 milliseconds for one cart and 0.09 milliseconds for the other. Since momentum is P equals mv, plugging in the values shows that the momentum before and after the collision is nearly identical, accounting for experimental error. This confirms that momentum is conserved during the collision. Now let's move on to the inelastic collision experiment using the Science Cube wireless smart carts. For the setup and data analysis tools, refer to the previous sections. The key focus of this experiment is to observe that momentum is conserved, but kinetic energy is partially lost during an inelastic collision. Prepare two carts and connect carts 230 and 246 via Bluetooth as before. Zero the values, then go into settings and set the data collection frequency to 50 Hz. Now we're ready to begin. Place the carts facing each other on the rail. One should remain still while the other is pushed toward it. As you can see, the Velcro causes the carts to stick together upon collision. This is the key characteristic of a perfectly inelastic collision. After the collision, tap the Stop button and examine the graphs. The graphs appear flipped, so let's use the same y-axis reflection method to adjust them. Here's the result. Before the collision, only cart A was moving while cart B was stationary. After the collision, both carts moved together at the same velocity. Using this data, we can calculate the momentum. The total momentum before the collision was 0.2625 kilograms. Rounded to the second decimal place, this matches the post-collision momentum of 0.263 kilograms, confirming momentum conservation. However, the kinetic energy is a different story. Before the collision, the kinetic energy was 0.069 J. After the collision, it's 0.035 J. The total energy lost is 0.034 J. In conclusion, while momentum is conserved in inelastic collisions, some kinetic energy is lost. Although we mainly used velocity data to calculate energy changes in this experiment, it's also possible to derive velocity and momentum from differentiated distance data. This concludes our experiments on momentum conservation and inelastic collisions using ScienceCube wireless smart cards. Thank you for watching.